Okay, thank you very much. So I'm presenting research called Identifying Language-Induced Mental Load from iBehaviors in Virtual Reality. So we basically designed a simple virtual environment and took information from psychology research about how your eye metrics change depending on your cognitive load. So for one of the most famous is that the pupil size is getting larger. And we were specifically interested in if people might look through the wall if they're thinking about something. So we call that focus offset. And so we had several samples of speech presented to users, and they were basically trying to comprehend their native language and then a language that a foreign language. And we were expecting that the foreign language triggers more mental load. And we used this language task because then people are like show free gaze behavior and are not using their gaze to do a specific task, but looking around naturally. And so in this situation, looking around naturally, hearing different samples, we analyzed it, and we had 4 samples. And the interesting thing is we noticed an effect, but this effect was strongest for the second most difficult sample, not for the most difficult one. And we were able to show this effect in pupil size, of course, that was the easiest. But also we got a significant effect in the in this looking through surfaces, although that followed less the pattern of pupil size, so we need to investigate that further. And we were able to show less fixations while concentrating. So we want to evaluate this focus offset metric a little more in the future. Thank you very much for listening.
Thank you. So I have a quick question for you. So what sort of the future works that you are trying to go for? Is there any particular directions that you thought your work will be able to contribute to the future in a way that, I mean, in the scope of the research topics that you are currently focusing on?
Yeah, thank you very much for the question. So, of course, the focus offset, like not directly focusing on the surface, is quite interesting. It hasn't been examined in virtual reality very much, especially because it's very difficult to calculate. It's quite unstable. So of course, I would like to investigate that more, but we need to remember that there might not be an actual relation to cognitive load. So I want to look at many other eye metrics, like the fixations were calculated in a like not the most ideal way in this research. So I want to, for example, make it easier to have a tool which detects, like, is good at detecting fixations from the 3D gaze arrays. Most tools do that for a screen scenario. But also, what can we say about cognitive state in virtual reality? Let's say like the general research. So for example, attention, we had some other papers doing that. Yeah, I think it's helpful for that, especially how to analyze the gaze information. Okay, thank you very much.
Yes, thank you very much for your talk and presentations. Thank you. Yep, so let's move on to the next presentation. Yep. So now we have the interview sessions for the next poster, which is the evaluations of predatory presentations of the conducting motions using tactile sensation for the visually impaired poster, which can be actually a long poster, but yet we will have the author to present their work. And please.
Hello, my name is Yuto Ueda from Keio University in Japan.
My research is trajectory presentation of conducting motions using tactile sensation for the visually impaired. I enjoy playing bassoon. A bassoon is an woodwind instrument, and I want to play with various people, but there is no visually impaired people in orchestra I belong to. So the reason, I guess the reason is that they feel a barrier to participate in orchestra because they can not see the conductor's motion like this. So I want to help them. So so we propose a method of presenting conducting motion and tactilely using multiple vibration actuators. So I conducted a quantitative evaluation to compare the baseline and my proposal method. So baseline is a point presentation. Point presentation is a method in which a single vibration actuator is vibrated in accordance with the timing of beats. So I use reaction time as evaluation metrics, and the results show my proposal method is better than a baseline method in some condition. Yeah, that's all.
Thank you very much. So a quick question for you. Do you have any future directions, or did you think that how can this will be help not only for the people with the visual impaired or maybe for any other general use cases?
General use case.
Yes.
Okay. And I want to play them in orchestra. So so they feel the trajectory from them back. So and they feel the conductor conducting motion. So we can play in orchestra with them. Yeah, that is the use case.
All right, that's definitely very interesting. Thank you very much. Yes, thanks again. So let's move on to the next person. Yep, so here we have our next poster, which is for the AR FPS game using static and dynamic physical obstacles. And we would like to have our poster authors to quickly run through with their poster and their contents.
Hi. We propose AR FPS game using static and dynamic physical obstacles. Here is an introduction. Existing studies propose VR and AR games to promote exercise, support running, and support rehabilitation. To enhance the immersive experience, VR experiences using physical environment have been proposed. Therefore, we propose highly immersive AR games using physical obstacles. In order for the players to enjoy exercising, we choose first-person shooting as our game. AR is used instead of VR because it is easier for players to recognize the real space. The proposed game is a game in which a player becomes a character in the game, avoiding enemy attacks and defeating enemies that appear around him or her. In order to avoid enemy attacks, the player needs to take action using physical obstacle in the surroundings environment. In this game, physical obstacles are classified into two categories, static and dynamic obstacles. Static obstacles include things that cannot move, such as walls. Dynamic obstacles include things that can move. Here is the example of game design. For example, object placement considering real space, an enemy attacking a player over an obstacle with a grenade, hiding behind a physical obstacle to prevent enemy attacks. Implementation, HORIZONs and Unity were used for implementation. Static obstacles were recognized using scene understanding. Dynamic obstacles were recognized using depth cameras built in HORIZON 2. We evaluated the game itself and the contribution from the use of real space. Each of the 14 participants played the game for 3 minutes and answered the questionnaire. The both game itself and contribution from the use of real space were highly evaluated. But some items low and comments from participants pointed that to be improved. Thank you for attention.
Thank you for your quick descriptions. So I have a quick questions for you. So have you ever considered any use cases for the outdoors? Maybe because since AR or maybe HoloLens could be one of the device when, for example, if you want to use it on the outside and there are some sunlight that can hinder the effect of the AR markers or the cues.
Sorry, please. One more please.
Yes. So technically speaking, so have you ever considered implementing the prototype on the outdoor with their very bright sunlights?
Outdoor play.
Yes.
This game, I considered play outside, but this system is need physical obstacles. So the scene understanding cannot recognize physical obstacle well outside. So this system is not do play outside.
Okay, thank you very much. So let's move on to the next presenter. Yep, so here we have our next poster presenter for the ASMVR for the light triggers in virtual reality to induce ASMR. And we will have the poster presenter others to quickly run down with the poster descriptions.
Yeah, okay, thank you. Autonomous sensory meridian ASMR is a tingling sensation that can help people reduce stress. And also ASMR can produce a feeling of relaxation and euphoria. So existing study categories 4 different kind of ASMR trigger: visual, sound, touch, and scenario. And light trigger is a sort of visual trigger. So at first, we analyzed some ASMR light trigger videos on YouTube that we want to have a primary impression on how the ASMR artists they help viewer to induce ASMR. So we found that there are 3 main points: the light interaction, ASMR sound, and emotion feeling. So based on our analysis, we applying them on our design. We created the ASMVR experience that we can not only help ASMR artists feel free to select and control different visual light source by using the VR hand controller, but also we can let viewer experience immersive ASMR method that help the viewer to feel intimacy and help them to induce ASMR tinglings. Yes, that's all. Thank you.
Thank you very much. So a quick question to you. Have you considered any using physiological sensor such as measuring heartbeats or in the future?
Yeah, I consider the haptics vibration in my future work, that because also the touch is another sort of ASMR trigger. So I want to combine them as a multi-mode interaction. Yeah, thank you.
Okay, thank you very much. So let's move on to the next posters. All right, so now we have our next poster for human copters wearable drone system for remote multi-directional teleoperations, and we have two other presenters today. So yep, let's invite them for the quick rundown for their poster.
Thank you. Hi, good afternoon, everyone. So our research is human copter. And in this research, we aim to provide a full directional cues to the user. And to achieve this, we propose human copter. So basically, we just attach the drone on the user with a shoulder mount and also with mounted on the helmet. And we also design some 3D printed safety protectors to for the safety measurements. So, and to evaluate our prototype, so we design a experiment. And in the experiments, we design a simulate environment with 35 points on the ground, and we will direct the user to walk around the points with 5 random points. And after the experiment, and we will give the user an interview. And in the interview, they feel like the force is actually clear enough, and they prefer to be not blindfolded because they feel like with blindfolded, they can feel the directional better. And if they are not blindfolded, they will try to defy the force when they see themselves walking to a border. Yeah, and thanks for listening.
Thank you for the really good rundown. So I have a quick questions for you. So have you ever considered in the future to use it in the implementations for maybe virtual reality or augmented reality, such as I would say that maybe some levitating effects or maybe some force feedback will be really important and really good to know for maybe future immersive technologies?
Yeah, that is actually our goal for the next step. So we will try to, first of all, we'll try to implement the whole system to a full body control. And after the full body control, we would like to implement it into maybe VR environments to be used in some simulated environments kind of thing. Yeah.
All right, thank you very much. Let's thank the authors again. So let's move on to the next poster. All right, so we have our next poster for the effects of spatial and temporal dilations of a brand logo printed on a VR shopping bags. And we have the poster authors to quickly run down for the quick descriptions of the poster.
Hello, my name is Moi. Moi Kihori. In this research, we research for a shopping bag, and in this we research for recognition of logos for is for logos and is for display methods. And in this research, the most recognition rate was most highest recognition display method was this 3D plus and footprint methods. And but in this research, well, we that in we that used via sorry, VR the used VR stores floor was nearest color and of this logo too. So and it was sorry, but the most recognition rate was the highest recognition rate was in the 3D plus footprint, but in logo 2, but logo 2 was the most lowest recognition, and we decided to we we read off logo 2 and search for this one, these three logos, and the most that one the most highest one was finally the most highest one was this method. Sorry. The survey of this experiment is about research about loss to on the shopping bag, but we search for these three logos and three methods, and the most highest recognition was this 3D plus footprint method, and but the where stores floors nearest of this logos number 2, but so the most recognition of logo 2 was the lowest one, so it need to it need the logo color have to differs from the floors.
All right, that's all right. No problem. Thank you very much. So because of the time, so let's thank the authors again for the presentations, and we will quickly move down to the next one. Thank you. Thank you. All right, so we have our next poster, lyrics on to cityscape, and we have the authors to quickly present the work for us for a quick rundown and quick descriptions.
We propose a new music experience that allows people to carry the music video like visual expressions matches to the cityscape. As a background of this research, high performance mobile devices made it easy to carry music anywhere else. The listeners like so. Yeah, so this is an attempt that allows the listener to carry a visual presentation that is matches to the situation, depending on the listener's desire to listen to this music in that place. As a first step, we developed a mixed reality system that dynamically projects and displays animation of the lyrics of a song onto a cityscape.
Thank you for the quick rundown. So I have a quick questions for you. So I think that, so personally, I have used HoloLens before, and I found that it is actually a very powerful device to track for the AR cues and also use it for the augmented reality interactions. But one of the, I would say the limitations that I have seen personally when using the HoloLens is to use them on the outdoor. So how did you overcome the challenge, or how did you decide to allow the people to be able to, for example, see the cues exactly, even though the sun is really bright, or maybe only does it work on during a specific amount of the time or during the day?
Actually, I tested this system when cloudy environment and not bright environment. Yes, in this system is difficult to use in bright environment, but I want to. So, I want to. So in the future, I want to this system to, for example, AR device, I like mobile device like AR. So, so okay. Using video see-through AR device, that issues, I think that issue is resolved.
So that's sort of like, for example, using the tablet to replace the HoloLens when the sunlight is really bright, and maybe we can switch back to the HoloLens when it gets to the comfortable level of the lightnings. Yep. So yep, that's very interesting, and can't wait for test the prototype actually by myself. So thank you very much again. So let's thank the authors again. So let's move on to our last poster for today. All right, so welcome back everyone. So now we are in the demonstration space for the ICAT-EGVE 2022. And now we will have our first demo presenter who is demonstrating their works for today. And yep, we will have him to quickly run down the project for us.
Hello, viewers. This is a demo of a VR programming in VR. So you can use these blocks to program in VR, have these 3D blocks. And this is intended for children to children's education of programming. And you can use these blocks and experience programming with moving these objects around in VR is inherently fun. So current programming education tools mostly use the flat 2D screens. And so with the metaverse being more being promoted right now and booming, we expect to have these kind of tools to be used in programming education, and we want to utilize the VR experiences.
Thank you very much. So how does it look like? I would imagine that people will be able to quickly use that in the VR. And have you ever considered, for example, when they use the print, for example, in the display, can they actually see a cube spawn in the real world? Have you had any sort of the considerations for that in the future?
Yes, we are considering more visual effects to be spawned, but we are more considering that the experience of actually manipulating these blocks to be more fun instead of having the result of these programs being fun. So that promotes more fiddling around, and failing is actually more fun than actually if you have to be successful in the program to have a fun result, that is not ideal. So you would want failures to be fun as well. So that is our concept.
All right, this definitely sounds very interesting for us. All right, yes, thank you for the authors again for the great presentations, for his demonstrations. So let's move on to the next demo presenter.
Thank you. Thank you.
Thank you. All right, so we have our next demo presenter today, and it seems like there is a really good and interesting setup in here. So maybe we could have the demo authors to present their work and quickly run down to what is going on in here.
Okay, this system is amplified coaster. You can experience roller coaster in here. Okay, and by inclination stimuli and visual stimuli and moving forward, you can perceive ascending and descending. Okay.
So it seems that the authors is going to do something to do with the gravitational. So let's have a look. How does it look like? So it seems that the authors are actually putting the participants into the wheelchairs, which is a kind of a really unique experience. But well, it seems that there is also another prop that's running on the ground to generate the initial force as well as the gravity force. Yep. So you said, how do you generate the gravity force for on the participants, or what sort of the scenarios you are trying to use in the setup?
Okay. One second.
Yep. So what sort of the immersive scenario they are using? Like, did they run in the grass field, or do they maybe play the car or something?
すみません、わかんないです。もっと、発展させていくってことですか。Okay. For example, in a park or parking area, you can experience amusement park attraction. Okay, so this system, the merit of this system is experiencing roller coaster in a limited space. Okay.
Oh, that's very good for the space management. All right, let's thank the authors again for his excellent demonstration. So let's move on to the next one. And thank you, Diane. All right, so we have our next demo for today, which is, we have also have a title, which is the experiencing high-speed slash session in virtual reality environments. And we will have the demonstration author to quickly run down what he is doing and what's going on in the virtual environments.
Hi, I'm Trans Kiyamoto from Meiji University. Our research is experiencing high-speed slash action in virtual reality environment. Our system allows any players to experience high-speed slash action as seen in films or video games. The system, in the system, when the system detects the start of the action, the system starts the exaggeration of the motion of the player. The exaggeration is predict motion of the sword and show the motion blur in advance. For this exaggeration, players can experience the high speed slash action than the actual player's slash action. Thank you.
Thank you very much. Thank you very much. So it looks like Fruit Ninja to me, but in a virtual reality. So have you considered any different animations for the slashing animations at all? So for example, as you can see in here, where we have the authors trying to present the works by slashing it in the virtual reality space, and they are sort of like a very quick, high-speed slashing generation. So have you considered any different effects in the future? Maybe like a fire or maybe a wind sort of the things.
I think for fire, water, or wind, and so I think make from many animations or films or video games. Yeah, thank you.
All right, thank you very much. So let's thanks the authors again for his great presentations. So let's move on to the next presenter for today. All right, thank you. All right, so now we have our next demonstrations today, which is the mingle with an amoeba. And it seems that we have a really interesting setup here for today, which is to use a really GUI interface to trigger the amoeba in the virtual environments. So it looks like the authors is trying to have someone to use the GUI sticky objects to present the sensations of playing a deformable virtual creature in the virtual environments. As you can see, the person is really enjoying the effects and also the sensations.
To scoop is very difficult. Yeah.
So it seems like they are trying to communicate with each other in terms of how much content they should put out.
Yeah, I get, well, it feels cool. Yeah. All right, thank you.
Okay. Yep. So now let's have the authors to quickly run down to about his works and also to see what is actually going on in the backend.
Oh, this work's main goal is making non-living thing like a real creature by using combination of visual effects and strange haptics of slime. Yeah. The system is there. We use hand tracking. To interact with the amoeba and the visual effects is called shield haptics. This presents this gives the users shield vibration feedback only by using visual effects. Should I say more?
No, that's all right. So thank you very much. So do you plan to create like a RPG game with a slime where people try to touch them? Anything like for the future?
Sorry, please say more again. Let's see. I haven't thought a lot about this, but to use this work, なんだろうな。let's see. Strange feedback, strange haptics feedback can make なんでしょう。ちょっと待ってくださいね。
So maybe they can try to detect the enemy more better, maybe?
もう一回お願いします。
はい。大丈夫です。
大丈夫です。
All right, so because of the time, so we might have to quickly run on to the next demonstration. So let's thank the authors and his amazing work again. So thank you very much. Okay, so we have our next demo, and the author seems to be doing his work in here, and there is going to be the boom machine evaluations of VR game experience with switching the presence of haptic feedback. So maybe we can have the author to quickly run down about what's going on in here and what is he trying to do.
Okay, so this demonstration shows the research of VR game with switching the presence of haptic feedback during play. By placing a physical mobile robot at the same position as a visible object in the VR space, the user can get a haptic sensations when he make contact with a target. On the other hand, by placing a physical object at the out of that position, the player get strike and don't get any haptic sensations. And we investigate how temporal patterns of the objects with haptics and objects without haptics change impressions on VR game experiences. Okay, so let me show how this system works.
Yep, so let's have a look at how it looks on into the backend. So is this thing heavy or is it really lightweight? So how many grams is it? Maybe 100 gram or 50 gram for the headset? I mean for the equipment, for the device?
Equipment? This toy hammer?
Yes.
Or, I don't know the detail. You have?
It looks like maybe 100. So yeah, that seems like a very lightweight equipment.
Not heavy, not too heavy. Yeah.
That's interesting to know.
Okay, let's start. Real entity and real entity. And I get a strikeout now. Haptic. And haptic. No haptic.
Oh, I really like the sound effect, especially when you try to smash it. It looks very stress relaxing to me. Well, all right. Thank you very much for your works, and that's really interesting to know your work today, and also keep going on with your good work. All right, so let's thank the authors for his great demonstrations again. Thank you very much. So let's move on to the next demo presenter. All right, so it seems that we have our next demo presentations for today, which is a demo based on moving interactions by controlling yourself in the virtual space. So that seems like they are trying to do something about how can they create the interactions by controlling their own self. So maybe we can get a closer look for really good details about what is the demo trying to do. So it seems that the user have to hold on to the objects in order to be able to control himself to walk around in the virtual environments. So maybe we can have the we can have the authors to quickly run down to what he is trying to do here.
We propose a method of movement in a virtual space. The user becomes a In this demonstration, we propose a method of movement in virtual space. And the user becomes a ball that can roll through the virtual space and is operated from first person perspective. There are several objects in virtual space which correspond to neutral objects in real space that match their appearance and movement. Yes.
All right, thank you very much. So how did the user can actually control themselves? Do they use the objects in their hands or do they have to use the controller to move their character?
The player use a controller to movement.
It's okay. Yeah, it's fine.
And what about the things that they are trying to hold on their hands?
Thank you.
Yeah.
Yeah, thank
Ah. Players used to player move to use club or stair or hand.
So let's have a quicker look into it. So it seems that there are multiple small objects here. So is that means when they try to hold the objects, is that going to be represented into multiple different virtual objects, allow them to maybe put into some places, or do they just will be able to interact by holding it? No problem. So I think that we have going to be running out of time. So let's thank the demo presenters again. So let's move on to our last demonstrations for today. All right, so here we are for the last demonstrations for today, and probably we could have the authors to quickly run down maybe 30 seconds to tell us about what it is doing and what they are trying to do in here.
Yes. Okay, so we have worked with the rendering. Should I take it? We have worked with the rendering. Is this fine? With rendering glinty granular materials in VR. So granular materials are, for example, sand or any material that consists of a lot of small granules. And that can be very challenging to render because it looks so different depending if you're looking at it closely or far away. And also when it's a glinty granular material, which means that individual granules are shiny, then that's also very difficult to render in real time. So yes, maybe I could just show like what it looks like. So our sand looks very different depending whether you look far away or I don't know if the or if you look very closely. It's like more detailed and it has glints that disappear at a distance. Yeah, and the way we have done it is using textures at close distances, which are procedurally generated, which we have a way for doing that. So you can choose what the texture should look like. What else? So we've solved the problems of having like very detailed textures up close, like what you would expect for sand, but very uniform appearance far away, and it's running real time, and the glints are stable. They're not like flickering everywhere. So yeah, this is something that's nice for VR because you can expect things very closely. Maybe otherwise you wouldn't care if you only had to see it from far away.
Thank you very much. That looks very interesting and challenging because how can you decide to optimize, especially with the performance in the virtual reality when they are trying to use and try to render all of the different amazing 3D objects. And I would really imagine that this can be really useful to create much more immersive and realistic environments for the user to experience and have a better embodiments and also use it, the performance for running through specific scenarios. All right, so thank you very much. So here we conclude all of the poster and the demo for today. And I hope you enjoyed that. And make sure that if you have any questions, feel free to post it onto the Zoom and also the Slack, likewise also the Discord, and let us know, and we can pop the questions to each of the authors for you. All right, thank you very much. And I hope you enjoy the rest of the ICAT-EGVE 2022.